Hello students, let's solve some more sums in exercise 14.3. Question number 3. If a figure has two or more lines of symmetry, should it have rotational symmetry of order more than 1? So answer is yes. As we have discussed earlier, I am just making a rough sketch of a square. In square we have found out that square has line of symmetry, 4 lines of symmetry, and order of rotational symmetry it is also 4. That is line LS, line of symmetry it is 4, and order of the rotational symmetry it is also a 4. In other shape also, for an example equilateral triangle, we have seen in equilateral triangle it has a line of symmetry of 3. And order of rotational symmetry is also 3. In a regular pentagon, we have seen that it has a line of symmetry 5 and order of rotational symmetry is also 5. So that means for a figure, if it has 2 or more line of symmetry, then it should have a line of symmetry or a rotational symmetry of order more than 1. So answer is yes. And the examples are equilateral triangle, square, regular pentagon. Next question number 4. Fill in the blanks. Question number 4. Fill in the blanks. Number 1. Here 3 columns are given: shape, center of rotation, order of rotation, and angle of rotation. In the first row, question is square. For square, we have to find center of rotation, order of rotation, and angle of rotation. What is the center of rotation? So here I am drawing a rough sketch of square. And what is the center of rotation? That means this one. That is nothing but an intersecting point of a diagonal of a square. That is this point. It is a center of rotation. So center of rotation in a square, it is intersecting point of diagonals. Now what is order of rotation? The order of rotation, as we already have discussed, that it is 4. And what is angle of rotation? That is 360 divided by 4, which is 90. So 90 degrees is the angle of rotation. Next, rectangle. Now in rectangle, what is the center of the rotation? It is nothing but an intersecting point of a diagonal. That means this one. This is the center of rotation. So center of rotation in rectangle, it is intersecting point of diagonals. What is order of rotation? Now here in a rectangle, all the sides are not equal. Opposite sides are equal. That is length and the breadth. So the order of rotation in rectangle is not same as order of rotational symmetry in square. So here for this we have to take one point A in one vertex in a rectangle. Now we have to move this point in such a way that this point comes here. When this A comes here, this same line is after rotating comes here, then only we get exactly same copy of a rectangle which was at the first place. So here what is the angle of rotation? That means this much, and it is nothing but 180 degree. Again we have to rotate for 180 degree. We get original position. What is the order of rotation? It is 1 and 2. That is 2. So order of rotation in rectangle it is 2, and angle of rotation it is 180. Next, rhombus. What is the center of the rhombus? It is nothing but intersecting point of diagonals. And what is the rotation? Order of the rotational symmetry? It is also here 2. As we can see that when all the angles of rhombus are not equal, and for that only when we rotate rhombus at 180 degree angle, we get exactly same copy. Again we rotate the rhombus in at 180 degree angle, we get original copy. That is original same. So order of rotation in rhombus it is 2, and angle of rotation it is 180, and center of rotation is intersecting point of diagonals. Next, equilateral triangle. In an equilateral triangle there is no diagonal but it is median. So the center of rotation is intersecting point of medians. Order of rotation, as we already know, it is 3, and angle of rotation it is 120. Next, regular hexagon. Hexagon is a polygon, so the center of the rotation will be intersecting point of diagonal. And what is order of rotation? As we have learned, for a regular polygons, how many sides are there? That many is a line of symmetry. And same, you have to keep in mind, for same, how many sides are there? Whatever many sides are there in regular polygon, that much rotational symmetry you will get. So in a regular hexagon, there are 6 sides, 6 equal sides, and therefore order of rotation it is 6. And what is angle of rotation? It is nothing but 360 divided by 6, which is 60. Next, circle. And circle, center of rotation it is its center of a circle, and order of rotation it is infinite. And what is angle of rotation? At every angle you get rotational symmetry in a circle. And next, semicircle. This is diameter and this is a half circle. So in this semicircle we take one point P, and when we rotate full turn, that is 360 degree rotation, then only we get exactly same shape which was at the first place. So order of the rotation in semicircle it is 1, and angle of rotation it is 360 degree. Now what is the center of the rotation? Center of the rotation is nothing but a midpoint of a diameter. That means this point, midpoint of this line segment, and this line segment is a diameter, so it is midpoint of a diameter. So therefore in a semicircle, center of rotation is midpoint of diameter, order of rotation it is 1, and angle of rotation it is 360 degree.